your studies so far? What do you think about nanomaterials or nanoparticles or nanotechnology, etc.?
Nanomaterials are basically materials in which at least one dimension is in the nano um, range, like from 10 nm to 100 nm range, 1 nm to 100 nm range.
Yeah, the size should be less than 100 nanometer. Yeah, but yeah, this is kind of some definition or things phenomena. So apart from this, what else, like in terms of applications, have you ever come across any kind of nanotechnology based product, etc.?
Carbon
Okay.
nanomaterials are used for as supercapacitors
Mm-hmm.
and in electric like uh, what we say electricity conduction,
Yeah, it
and there are
can be
also
used.
medical applications
Mhm.
like nano electric transmitters.
Yeah. So let's see. I mean, what are the applications behind with nanoscience and nanotechnology and their, I mean, fascinating things. Okay. So nanoscience, if you see what is nanoscience, it's a study of phenomena or the manipulations of materials at atomic or molecular level or even macromolecular scales, where their properties are completely different at that scale. I mean, if you, in the sense, if you make any material, okay, in the sizes of less than 100 nanometer or 1 to 100 nanometers, their properties are completely different. That means they behave abnormally as compared to the bulk material. Okay, and what is nanotechnology is that if I mean the technologies are the design and characterization or the production and applications of those derived structures. I mean, in terms of fabricating either devices or systems by controlling their shape and sizes of the nanomaterials. Okay, which is called the nanotechnology. Okay, that means I mean you are first you are going to fabricate some nanoparticles or nanomaterial at the controlled shape and sizes, and with the help of those prepared nanomaterial again, you are going to fabricate some devices or some sort of like structures, okay, for certain applications which has some desired properties. And yeah, all about the understanding and control of material or the matter at dimensions of roughly 1 to 100 nanometers. Okay. And if we see the applications or the products so far, what we have like nanoscience and nanotechnology based things, I mean, it's kind of interdisciplinary efforts. It was, I mean, discovered by the combinations of chemists, physics, and technologists, and biologists, and of course, doctors, etc. Okay? I mean, it has combination of various, I mean, engineers and, I mean, scientific peoples. Okay? I mean, including the information technology. And why is it so attractive? Because the moment when you reduce the size of the nanoparticles, okay. By the way, one more thing. Um, whoever knows how to read the microscopic images, everyone knows, right? If I give some microscopic images and if I ask you to analyze the particle size, how do you analyze it? You have studied ACM term, everything, right? Say, for example, here, yeah, you can see here ACM images. If I ask you to measure the size of this kind of some images, I mean some odd structures which has some kind of needle-based one, or some this kind of the kind of some spheres. How do you analyze it? You have a scale bar here, and directly you can fit it there. So I hope everyone knows, right? Why everyone is silent? Either you should say yes or no. Om Prakash, you know, right? And if I don't give you the SEM, I mean macroscopic images, how do you analyze the particle size of the material? I mean the particles.
So with SEM, yeah, we can fit with the scale bar. That's
Yeah,
your
and
question.
if
Yeah, we know.
okay, if I don't give you the SEM and if I directly giving you some material and ask you to do the analyze the particle sizes, how do you analyze it? Apart from these microscopic images, there are other techniques. So you can use either light scattering in the sense like a particle size analyzer, and you can also use some other techniques called AFM and all. Okay. I mean, just for information. So with the help of those tools, you can measure the particle size of the prepared nanomaterials. Okay. Why they are so attractive? Because they have been used almost in every field, like information technology for storing the capacity, increasing the capacity and reducing the, size of the devices, and energy. Of course, it has been used widely in solar energy applications. And health, there is no, like a limitation. It has been used in most of the applications, like it has been used in drug delivery and diagnostics for, most of therapies like cancer, etc. And it has also used in the tissue regeneration and for the environmental purpose. I mean, they have been used for water, filtration purpose, as well as for desalination, as well as for using it. It has been used for nano sensor. And of course, if we see how small the nanomaterial, so like our hair, if we measure the diameter, which has, with the 0.1 mm, and roughly you can say like 100 micrometers. So this is how the single nano has, if your hair is very kind of nano ranges, this is how it looks like this. So one hair has like kind of 1 lakh threads of your, hair. So which has that much of like a higher surface energy as well as surface area. Well, nothing was created. It was already existed in the natures. Okay, if you see your, macro, like your tissues or organs in your body. If you measure the size, scale of your various organisms, like either DNA, RNA, or any kind of tissues like blood vessels, etc. If you see the scale bar, they ranges from centimeters to micrometers. Okay, and yeah, of course, the blood vessels are in the range of micrometers. And if we measure those kind of DNA and their protein structures, etc., they are in the ranges of in the scale of nanometers. Okay, so that means nothing was created. Okay, it was all discovered from our nature itself. Of course, the butterfly wings. If you see their they measure the scale of their different things, like they also ranges from centimeter to micrometer. Okay. Okay. Right. So this is how they categorized. From things which are man-made to the natural things. Okay. So first they, analyzed the natural, might to say blood cells, and then fires, and then ant. The sense like their wings or the legs, etc. And then they also slowly, they analyzed the, protein structures and atoms, how exactly the atom sizes, etc. And then slowly, they fabricated all these structures, using our technology, like 3D printing, etc. Okay, you can see here, these things are used in the MEMS, actually, micro electromechanical devices. So you can see here the small screws, which has a, scale of like 2 micron or 3 micron. Okay, so they are widely used in MEMS. Even your computer microprocessor system also they have been used, actually. And this is head up, and you can see the sizes like 1 to 2 mm. That means like all you have to do, manufacture through observing through under the microscopy. Okay. So of course, yeah, carbon nanotube, which has the diameter of less than 100 nanometers, and then yeah, there are things called like carbon buckyball, even which has a different carbon isotopes. Okay. So why do you want to make things at nanoscale? Because if you see their properties, they have got, more excellent, increment in the properties, including, electrical, mechanical, or other biological characteristics. And yeah, they have been used in almost all the sectors, like including, catalysts and electronics, solar cells, coating, etc. And the best example, like what we are using in the iPod, like you can see the sizes of iPod in 2001 and 2004, etc. So slowly size is getting reduced because the materials what they are using now, we don't have to use quite large amount of material because they are reducing the size of the material. As a result, they have got more surface energy and surface area, and that is much more capable to have those kind of properties. All right. This is some of the few examples of sizes of those eyes of fruit fly and then bristle, etc. And this is the virus and DNA structures. So you can see the sizes of virus and DNA. I mean, even the DNA structure, you can see it is in 2 nanometers. And yeah, as this fellow, I forgot his name. He was telling it. I forgot his name. Yeah, Gupta. So he was saying that one-dimensional, two-dimensional, etc. So now comes to the question, uh, how the geometry of the nanomaterials should be. We have seen the particle sizes, the nanomaterial should be in the sizes between 1 nanometer to 100 nanometer. That's fine, but yeah, how good the geometry of the nanomaterial? So it could be of any sizes, like one-dimensional, two-dimensional, three-dimensional, etc. In the sense, it could be the shape of spherical or nanorod or the fibers, etc. And it could be of the shape of cubic as well as the disc type based structures. Yeah, this is some of the few examples where exactly things are used in a technology-based product. Okay, you can read out. Automotive industry and chemical industry and medicines, etc. So now, so how the surface area is reducing? Increasing. Okay, it's a very simple question. You take 1 kg of sugar. The solid sugar. Okay, and put it in the water. It takes long time to dissolve. But if you crush the sugar, if you make some fine powders and put it in water, you can see they dissolve very pretty much faster. Okay, so that is one of the example. If you reduce the particle size, the reactivity will be pretty much fast, as well as it will occupy very less volume. Okay, as compared to that of bulk material or the macro material. Okay. And there are some few special things used to happen, you can see some of the applications here. This is some bulk aluminum and this is nano aluminum. Okay, the bulk aluminum, there is no, it doesn't have that flammability characteristics. But if we make aluminum into nano aluminum, and if you, if you take the fire, near to that, nano aluminum, they catch fire immediately. Okay. So this is how the property changes completely when you reduce the size of the material. And not only that, reactivity and melting point and mechanical strength, conductivity and color is also like. You can see here the bulk will used to look in the form of a strong yellowish color, but the moment when you make things into nano gold, it transforms into the fluorescent color or the kind of pink color. Okay. And these are some unique characteristics of nanomaterial or the nanoparticles. If you see the nanoparticle, they have a very large surface to volume ratio and high percentage of atoms and molecules used to presence on the surface. Okay, so as a result, they used to react more with other substrate, and they used to enhance the technical properties very easily. Because surface forces are very important, while bulk forces are not as important. Okay, because surface usually, used to, experience either the forces or any kind of other reactivity with the other substrate. And metal nanoparticles have unique light scattering property and exhibit plasma resonance, and that's the reason. It can be used for supercapacitor as well as superconductivity, etc. The semiconductor nanoparticles may exhibit confined energy states in their electronic band structures. So the best example is quantum dots. Okay, and there are some, kind of particles. If you change the size, even from 20 nanometers to 50 nanometers, you can fine tune their biological applications. Okay, so we'll see some of the examples at 30 nanometers, how they are using I mean, taking those nanoparticles for biomedical sector, and if they increase the, I mean, diameter, I mean, slightly higher, like 3 nanometers, how the application they are using. Okay. So this is some of the unusual, I mean, properties, examples. Okay, okay, the phase transition temperature. Okay, you might have seen in the, I mean, metallurgy, like to have certain structure, you have to quench the steel. I mean, at certain temperature, etc. Okay, and you have to keep it for a long time. So also, I mean, dwelling time, etc. So with the help of these nanoparticles, you can reduce those transition temperatures. So once you reduce those temperatures, even 10 degrees Celsius, it matters a lot for the industry people. Like you can reduce a lot of energy, you can save a lot of cost, etc. Of course, with the help of this nanoparticle, even if you reinforce like 0.5 percentage of filler into material, okay, or say for example 0.5 percentage of carbon-based nanomaterial into your steel, you'll get, I mean, having a significant improvement in the mechanical properties. Not only that, sometimes you have to have this improvement in the properties as well as you don't want to, I mean, sacrifice the transparency. Okay, in the sense, even you reinforce nanomaterial, the optical property will be retained as much as. So there'll be no I mean, changes in the optical properties. And you can fine tune the electrical conductivity and magnetic properties, etc. Of course, the biological responses like targeted drug delivery as well as the targeted tissues and photodynamic therapy for killing those cancer tumors. So all these things can be done only with the help of nanoparticles. And the physical properties of nanoparticle, of course, I mean, the technical properties are completely dependent upon various things like size and geometry and their composition, I mean, chemical composition, of course, the crystal structures and the surface modification. Like, say, for example, if you want to use some metal nanoparticles and if you want to use them as a reinforcement in polymer-based matrix, you have to modify their surface either with the capping agent or the ligands or some submicron. This is some other pre-calculation. This is nothing much here. I mean, you can do yourself. Okay. So, say for example, if your particle is spherical, that means they have only one dimension, which is called either diameter or the radius. Okay. So here, like this is how they used to calculate the surface area and the volume. So this is volume. I mean, surface volume formula, and this is surface area pi r squared and pi d cubed by 6. And if you put the value of diameter, and you'll get all these values. Okay. So once the surface area increases and volume will be decreased. Okay. So as a result, you can save as much as space, I mean, for storing the materials. Okay. So here some of the tables, like if you have a 1 nanometer diameter, you see how much the surface to volume ratio. When you increase the diameter, how the surface to volume ratio is decreasing, etc. So yeah, this is how you see the bulk metal. It's a bulk cube actually. This is how much space it occupies. But once you reduce, I mean, increase the surface area or reduce the particle size into as small as possible, you can see how good you can see the, I mean, vacant spaces. I mean, how much space you can save it. Okay. Not only for saving the space actually, the reactivity. So now you can see the number of surfaces exist in this material. As a result, once the surface is exposed to this other substrate, the reactivity will be pretty much, I mean, fast actually. Reactivity in the sense that could be of anything, kind of a secondary interaction or for catalyst purpose or for the mechanical interlocking, etc. So it has multiple jobs. And yeah, this is one of the typical graph, like surface to volume ratio. Once it is, I mean, decreasing, how the nanoparticle is, changes. So this is some of the scheme, like one-dimensional, two-dimensional, and we do have a three-dimensional material and zero-dimensional. Zero-dimensional means the nanoparticle doesn't have any shape and sizes. Sometimes you can see the coarser nanoparticle and which is also open actually. And yeah, there are some nanoparticles which are encapsulated into that hollow nanosphere. So this is how they used to define zero-dimensional nanoparticles. And one-dimensional means it has either of like kind of either spherical in diameter or kind of continuous fiber. Okay, that means you can see carbon nanotube, which is pretty much long. I mean, very high in length, but the diameter is very uniform. So So that is how they used to define. I mean, carbon nanotube usually comes under the category of one-dimensional. But on the other hand, if you see the nano rod, actually, like so, if you see the nano rod, which has defined length as well as width of the diameter. So the nano rod comes, I mean, into the category of two-dimensional nanomaterials. Yeah, this is example carbon nanotube actually, and this is example for spherical. Okay, this is microscopy obtained from the transmission electron machines, and this is zero-dimensional coarser nanoparticles. And this is two-dimensional nanorod. You can see, I mean, having the defined length as well as width. I mean, maybe a 500 nanometer length and maybe a less than 100 nanometer width actually. And you can see here some of the 3D material, like you can see some unusual dimension, like kind of flower styles as well as some cubes based, I mean, geometry. So those are, I mean, categorized as the three-dimensional nanomaterials. And we also have some mesoporous based nanomaterials. Say, for example, if you see the nanomaterial, I mean, on top of that, you can find some of the porous structures exist in the nanorod. So that is what it is called two-dimensional mesoporous nanorod. They are widely used, I mean, for I mean, drug delivery application as well as for thermal conductivity purposes. Because if you have the more porous, I mean, the foam-based structures, they can conduct energy very easily. Okay, so mesoporous materials is a material containing pores with the diameters between 2 to 150 nanometers, according to the IUPAC nomenclatures. So again, you can see some of the 3D nanoflowers. Okay. So now, why size is so important? It's not that only the optical property changes. You can also fine tune their, I mean, the optical properties. Okay, so the same nano, I mean, sorry, silver material. Okay, sorry, silver as well as the, I mean, gold nanoparticles here. Okay, so you can see here silver nanoparticles, which was fabricated at a size of 100 nanometers. You can see, I mean, how good when you transmit the light, either UV light or IR, how the emit, I mean, the light is getting emitted. And the same light, sorry, the same nanoparticles, silver nanoparticles, if you are slightly increasing the size of the nanoparticles, you can see the changes in the color of the nanoparticle. So this is how, I mean, they used to manipulate the nanoparticles for obtaining some special properties by changing the, atomic, scale, etc. And this is one of the graph where the melting point is getting, lowered with the with reducing the particle size of the materials. Like this, and now here the example is gold nanoparticle. Okay, the moment when you increase the sizes, you can see here. If you increase the size of the diameter of the nanoparticle, you can see the increase in the melting point. Okay? Or the vice versa. If you reduce the particle size diameter, you can see the reduction in the melting point. Okay. So time. It's 2:30 fine. So is it fine? So as of now, even we didn't get into the topic still. Still, we are in the introduction section. Yeah. Still, if you don't understand anything, please we can discuss now. There are total 21 students, right? Why yesterday was also 8 students and today also 8? Anand, they are not interested or what?
Sir, few of them have dropped, sir. I think it's less than 21.
No. Only one girl dropped actually. Anyway, so just, I don't care if they come or if they don't come. I have made one quiz session on 3rd September. So you have still time, 2 weeks. So just for your information, okay? I hope it should be visible on your dashboard as well. And you have to, write one assignment also. Maybe tomorrow I'll discuss I'll decide what's the assignment. And yeah, anything else? Okay, see you on Friday. Tomorrow is a holiday, right?
Yes, sir.
Okay, fine then. See you.
Thank you, sir.
Yeah.
Thank you, sir.